So in this tutorial, I'm going to be showing you guys how to find all the residues on the surface of a protein. So for our tutorial, we're going to be looking at matrix protein 1 of the influenza protein. I'm just going to fetch it by ID, and its PDB code is 1EA3. So if I reorient this molecule a little bit, you can tell that it is a dimeric protein. It seems that it is a homodimeric protein, meaning that these two chains are the same. I'm just going to make it a little bit easier to see visually, so I'm going to go to Presets, Publication 1, and this just gives it a white background. So the first step, I'm going to be going to Action, Atoms and Bonds, and we're going to show all atoms and bonds. This just computed all the residues on the surface of the protein. You're also going to notice a couple of these little red dots floating on the outside. These are actually just water molecules. They're not going to be important in our calculation because we're only concerned with the residues associated with the proteins. So next we're going to calculate the actual surface of the entire protein. We're going to Action, Surface, Show. It's going to take a second here. But basically what it did is it calculated both the solvent excluded surface area and the solvent accessible surface area for each atom and each residue. According to what I know, the solvent accessible surface area is everything on the outside or the surface of the protein that the solvents like water would be able to contact. The solvent excluded surface area would include all the residues in the interior of the protein, and the solvent wouldn't be able to reach these. So this just looks like a big mess. Visually, we're not really sure what we're looking at. I want to be able to quantify this, so we're going to go to Tools, Structure Analysis, and we're going to use a tool called Render by Attribute. So we're concerned with the attributes of residues, so we're going to select that. There are two tabs here, there's Render and Select. We're not going to be concerned with the Render tab. The Render tab actually just lets you color specific residues on the protein according to area. This does require you to know what residue indicates what area. At this point, we're not really too sure. So I want to be able to select each residue and learn about each residue specifically. So we're just going to pick the Select tab. We're going to choose Attribute. And like I said previously, we're concerned with the solvent accessible surface area. We don't really care about what's on the interior of a protein. So we're going to select this. Now this is basically a histogram of the solvent accessible surface areas on the outside of the protein. These green bars delimit the range of the areas that's applicable. So just to make sure that we're not missing anything at all, we're going to make this range as wide as possible. So I'm just going to take this bar, make it 0. That's going to be our lower limit. And this green bar on the right here, this is our upper limit. So the max seems to be 227.032. Now what I'm actually going to do, I want to make sure that we're only looking at the surface proteins. So this lower limit here, I'm actually going to make it 1. So it means that all residues below 1, they're likely going to be on the interior of the protein, and we don't want to include those. But I'm going to take the outer limit, and I'm going to make sure that we're not missing anything on the outside. So I'm actually just going to extend it a little past this default range here. We're going to make this 230. So I'm going to select between the markers. So at this point, it means if I press apply, we're going to find all the residues on the surface of the protein that have an area between 1 and 230. So I want you guys to be able to see what's going to happen. So I'm just going to hide this surface area here. Now I'm going to press apply, and it highlighted virtually almost every single residue on the outside of the protein. So even then, it's a little bit confusing visually. Now if you want a comprehensive list of all the residues as well as the actual surface areas, you just go to File, Save Attributes. We're just going to give it a fancy name. We're not looking at buried, we're looking at the residues on the outside. So we're going to call it 1EA3-surface.txt. It is going to be a text file, which is a huge ass list. So we're going to use the txt suffix, and we're going to restrict the save to current selection. I already did before, so I'm just going to overwrite my file. Now, just for comparison, I want to show you guys the interior or the solvent excluded surface areas. So I'm actually just going to press outside the markers, and this is going to not look at everything here, but what's on the inside. Theoretically, there shouldn't be too much, but it's going to highlight it if we missed any. So if I just press apply here, and as you can tell, it highlighted the interior of each chain. So I'm also going to file save attributes. We're going to call this buried. I'm going to overwrite this. So at this point, we have two text files representing the surface areas of all the residues of the protein, both the outside and the inside. I'm just going to open these files. Okay, first let's look at the surface residues. So this is basically your comprehensive list. Don't really worry too much about the colons. The notepad contains colons because colons are basically just the syntax for residue numbers that Chimera uses for its command box. We don't really have to worry too much about this. If we're looking at what this means, colon 2.a means that this is residue 2 of chain A. Like I previously told you guys, it looks like we have a homodimeric protein. So this would just be related to chain A specifically. So the numbers that you see here represent how many residues with solvent accessible surface areas between the range of each chain. So it looks like for chain A, there are 158 residues on the surface. The right column here is just the surface area of each chain. In chain B, it looks like there is also 158. So this also confirms the fact that it is homodimeric, meaning each chain is exactly the same. Okay, now I'm going to open up the buried file. So it did highlight quite a couple. We did set the limit from 1 to 230 in terms of surface area. So theoretically, if I open the lists, all the residues will have areas either less than 1 or greater than 230. And it looks like I was right. So most of them are 0, meaning they're outliers, we don't really have to worry about them. There are some residues that have less than 1 square angstroms of area, but it looks like these aren't really too concernable and there shouldn't be any interactions with solvents.